Okay, uncertainties. Just a quick go through uncertainties. Okay, so if we've got an equation like this, speed equals distance over time, and we're calculating speed, we can calculate the uncertainty in speed if we know the uncertainty in distance and the uncertainty in time. So let's say that we've measured a distance, and that distance is exactly 74 centimetres. So if we've measured it with a metre ruler, we can put it to the nearest millimetre. Okay, so make sure that you record things to the right precision. Now that measurement would be, if we've used a metre ruler, it's going to be plus or minus 0.001 metre. Okay, so that's not a percentage uncertainty, that's an absolute uncertainty. It's the smallest increment something will measure. Now let's say we timed whatever it was, and the time it took to go 74 centimetres, it must be a snail or something, it took 2.74 seconds. Now if we're timing this using a stop clock, we're going to have the uncertainty is going to be our reaction time. I want you to take reaction time to be half a second, please. There is a range that it's allowed to be, but half a second fits within that range. Now, if I wanted to know what speed this was going, then I would be doing 0.74 divided by 2.74. It's going at a speed of 0.270 metres per second. Now, I've written it to 3 sig figs because I know that to 3 sig figs. I possibly know that's 3 sig figs, but do I really? Because that is my uncertainty. Now let's have a look at these uncertainties. If I want to be able to find the uncertainty in my answer, I've got to find the uncertainty in these two things, the percentage uncertainty in these two things. So the first one, to find the percentage uncertainty, I do the uncertainty, 0.001, and I divide it by the measurement, 0.74. To put it into percentage, I then multiply my answer by 100. And it's going to be a really small percent. It's going to be, let me put it in a different colour. The percentage uncertainty is 0.135%. Okay, I'll worry about my sig figs later on. Now, working out the percentage uncertainty in this one, I do 0.5 divided by 2.74. I multiply it by 100 to get it into a percentage, and that's 18.248%. Okay, now this means the percentage uncertainty in my answer, I have to add that percentage uncertainty to that percentage uncertainty, and my percentage uncertainty works out to be, well, it's still just over 18%, 18.383%. Now it might be then that I've got to put that back into an absolute uncertainty. So what I would do is, if I know it's that percentage of 0.270, I can take that as a percentage of 0.270, and it comes out to be plus or minus 0.0496345, blah, 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 blah. Now, having a look here, I know this to the nearest 0.001 metres per second, so I will probably write it 270 metres per second plus or minus 0.0, I suppose it's 50 metres per second. So that's what I think the speed is, finding my percentage uncertainty from up here and turning it into a percentage uncertainty of around 18% here. Okay, so that's how you work out percentage uncertainty. And if it's something where you're timesing or dividing, you add the percentage uncertainties. Now, sometimes it'll make it slightly more complicated. Like, for instance, here, if I want to find what V would be, if I want to calculate V instead of measuring it, I've got to look at what my uncertainties are along the way. Now, if I've measured the current to be 1.17 amps, I can say that that's good to the nearest 0.01 amp, okay, the smallest increment that it could measure. Now that's going to be a very small percentage uncertainty. If I just work that out, it's coming out to be 0.847%, okay, so plus or minus 0.8547%, okay, tiny percentage uncertainty. I'd have to think about my sig figs. However, here, to find the total resistance, because they are in series, I'm going to add the two resistances together. So I've got 47 kilo ohms plus 79 kilo ohms. The total resistance there, 47 plus 79, is 126 kilo ohms. Now, to work out the total uncertainty, well, this one is 42 kilo ohms plus or minus 10%. Well, 10% of 42, that's 4.2 kilo ohms. Okay, this one, 79 kilo ohms plus or minus 5%. 5% of 79 is 3.95 kilo ohms. So plus or minus 3.95 kilo ohms. So if I want to know what the total uncertainty is for the resistance, because I'm adding those together, I've got to add together the absolute uncertainties. So this 126 kilo ohms is going to be plus or minus, if I add 3.95 plus 4.2, I get 8.15 kilo ohms. So adding, you add together the absolute uncertainties. Timesing or dividing, you add together the percentage. Now I know what the total uncertainty is. What I can do is I can turn that into a percentage uncertainty by dividing that 8.15 by 126 and multiplying by 100 to get it into a percentage. It's 6.47%. Okay, so it's 126 kilo ohms plus or minus 6.47%. Now what I can do, if I want to work out what the percentage uncertainty is in my current, is I will add 6.47% there to 0.8547% there. So if I add those on, 0.8547, I've got a percentage uncertainty, a total percentage uncertainty in my current, my potential difference, V equals I times R. Whatever V is, I will know the answer to plus or minus 7.3%. Okay, so next thing is I've got to find out what V is. I know I is 126 kilo ohms. Sorry, that was R. I know I is 1.17. So if I do 126,000 multiplied by 1.17, I've got my potential difference to be 147,420. I only know it to 2 sig figs actually. So I'll put it as 1.5 times 10 to the times 10 to the 1, 2, 3, 4, 10 to the 5, plus or minus 7.3%. And again, what I could do is I could take 7.3% of that number and put it as an absolute uncertainty instead.